Hi, my name is NURUL and I'll be explaining the critical path method for the proposed construction of double-story bungalow house unit in Seri Iskandar, Perak. Based on our estimation, the duration of this project is 554 days, around 22 months of completion. The cost of this project is RM280,474.75. This project will be starting on 1st July 2021 and estimated to complete on 10 May 2023, starting with site possession on 1st July and continue with the preliminaries work, building work which consists the structural works, ground floor and first floor architectural work, ground floor and first floor mechanical, electrical and plumbing work. The 3.6 is the external works and followed by the closing works. The cost for site possession is RM1,000. The preliminaries work costs around RM23,450. Building work for RM255,352.75. Next is closing works cost RM672. As you can see in the preliminaries work, there are site clearance, setting out, temporary water supply, temporary electrical supply, insurance, project hoarding and signboard, temporary access. Under building works, structural works, there are pad foundation, ground beam, ground floor slab, ground floor precast shear wall, ground floor precast column, first floor precast beam, first floor precast shear wall, installation of shade roof, and private swimming pool. This is the financial and physical S-curve generated from the Microsoft Excel. This graph including cumulative cost and cumulative percent complete from the critical path method.
Bismillahirrahmanirrahim. My name is Asyraf and I present to you the mechanical, electrical and plumbing of our proposed construction of double-story bungalow house unit. For the electrical section, it can be divided into two, which are the power and lighting. Firstly, let us look at the ground floor plan for the power. In this house unit, we are using duplex receptacle ground fault circuit interrupter GFCI. The connection type is breaker and all of the sockets are paneled to a 600M 3-phase 208 volts. As you can view on the whole ground floor, we are applying chamfered wire as type of wire arrangement and the total sockets in the ground floor are 22 sockets. Similar to the ground floor, duplex receptacle GFCI is used for the sockets with a total of 18 sockets in the first floor. All of them are in chamfered wire arrangement and every single spaces has a minimum of 2 sockets. Alright, moving on to the lighting floor plan. As you can see, the wiring arrangement is also using chamfered type in the ground floor. The total of 5 circuits are connected as breaker to a 600 amp 3-phase panel board. In contrast, a combination of arc wire arrangement and chamfered wire arrangement is implemented in the bedroom 4 and 5 in the first floor. There are 5 circuits in this floor connected different spaces. And in this building, different types of lighting features are used according to the spaces. There are 58 units of round ceiling lights in the bedroom, bathroom, kitchen and living hall. 2 units of these pendant lights are used in the living hall and balcony. Meanwhile, a total of 9 unit side-mounted recessed light in the first floor living hall. Hemisphere pendant light is used in the dining area and 5 units of linear pendant light in bedroom, gymnasium and living hall. Furthermore, there are 2 types of piping system which are sanitary and domestic cold water supply. As referred to the drawings, the cold water is in blue color while the sanitary piping in the green color. In all buildings, the cold water is supplied directly from the Lembaga Air Perak, and some of the features available in our buildings are bathtub, water closets, floor drain, kitchen unit, mop and work sink and shower stall. Alright, to get a clearer view, here is the elevation of the piping system. The cold water supply is embedded 1 foot while the sanitary is 2 feet below the ground. The quantity and price of the plumbing system is tabulated in the drawings. And lastly, these are some of the examples of our plumbing perspective view in our buildings.
This is our precast analytic structure. The precast element is beam, column and shear wall. The structure are designed and constructed to withstand external loads without moving. Based on the concept of shear wall in the bungalow structure, the shear wall structure is arranged in both directions of the shear wall, which is the direction of two main axes of the lateral stiffness. The bungalow designed with shear walls to provide resistance to shear forces. So next is the bending moments. The bending moment is bend when loaded at any point along its length. To calculate the bending moment for the bungalow, the magnitude of the loading is multiplied by the distance of the loading from the point of support. So the loading condition for the bungalow is dead load, live load and wind load. So this is the loading condition that adopted for the analysis. So firstly is the dead loads. The dead loads are a self weight of floor slab considering 150 mm thickness. So 0.15 times 24. 24 is the unit weight of precast reinforced concrete equal to 3.75 plus 1. So the dead loads for the self weight of floor slab is 4.6 kN per meter. Next is the shear wall load. The shear wall load is 15 kN per meter. And the last one is live loads. Live load on floors. So the bungalow floor area is 292.17 meter square times with 1.5 kilopascal, which live load rating of house is 1.5 kilopascal. So 292.17 meter square times with 1.5 kilopascal equal to 438 kilonewton. Therefore, the live load of the floors is 438 kilonewton. Next, we move to the structural column schedule and wall schedule. For the structural column schedule, we use precast rectangular column with the size of 32 inch times 20 inch. And there are 20 total of column we use for the bungalow. And the price for each column is 706 ringgit and 80 cents. Next is the wall schedule. For the wall, we use precast shear wall. And the price for the shear wall is 213 ringgit and 50 cents per meter square.
Assalamualaikum, I am KHAIRYN and I'm going to present about energy performance and sustainable analysis. The energy performance and thermal comfort of an existing building in order to decrease the structure's reliance on its mechanical system through retrofit methods. The energy performance focuses on the bungalow unit double story in Seri Iskandar, Perak. The color on custom solar is from warm to cool. The yellow color indicates where the sun radiates the most and the blue color indicates less influence from the sun. The sun study started from 7:13 am until 7:23 pm on 7th July 2021. The yellow color mostly on the roof of the house as the sun directly radiates there, meanwhile the red color influence more on the wall. The blue colors is a cool areas inside the house or blocked by the roof. For the sustainable analysis, the net energy use intensity of the design is 190 kWh meter square per year. The AZMI 90.1 benchmark provided for this building design is 147 kWh. For building orientation, any orientation other than 0 degree and 135 degree will result in a substantial increase in the building total energy use intensity. For achieving any amount of the energy savings is used up to 15% window wall ratio in south and east facing wall. The window shades at height between 1/6 and 2/3 of the window height on the west and east can reduce EUI by 1% to 10%. A R13, R10 metal or 40-inch insulating concrete form was used as the wall material. Almost 7% of the energy used by the building can be conserved. From the graph, using both the lighting and occupancy controls can be reduced the net energy used by almost 5%. That's all from me. Thank you.